Since the beginning of the space age, mankind has developed many new technologies to help better study the universe, our galaxy, the solar system, and look for evidence of extraterrestrial life. However, just a few missions ignite the imagination like Voyager 1. First launched in September of 1977, the roughly 1,800-pound space probe careered toward the outer edges of the solar system, surpassing the distance of its sibling Voyager 2 in December of that same year. Voyager 1 was the first spacecraft to exit our heliosphere, becoming humanity's first emissary among the stars. Now, after 46 years, the spacecraft still communicates using the Deep Space Network. However, Voyager 1 found that interstellar space is a lot weirder than we thought. In the blackness of space, billions of miles from home, the most distant human-made object from Earth is behaving weirdly. It's sending nonsensical ones and zeros back to Earth. Engineers and scientists attempted to reboot, but according to a NASA news release, it did not help. Obviously, it's not easy to diagnose and fix problems from 24.4 billion kilometers away. But what exactly is causing the spacecraft to transmit this mishmash of data? Is this just a small technical glitch, or could the end finally be near for the iconic spacecraft? Let's uncover the real reason why Voyager 1 is sending a strange signal from interstellar space. The prospect of Voyager's grand tour of the outer planets emerged in 1965 from the musings of an aeronautics graduate student named Gary Flandreau, working at NASA's Jet Propulsion Laboratory in Southern California. Assigned to envision possible missions beyond Mars, Flandreau plotted the future positions of Jupiter, Saturn, Uranus, and Neptune. He found that they would align in such a way that a spacecraft could tap the planet's orbital momentum to slingshot from one to the next, gaining enough velocity to visit all 4 planets within 10 or 12 years. The mission launch window would open for a matter of months in the late 1970s, then close for another 175 years. It was an ambitious idea at a time when no probe had ever functioned for anything close to a decade in space, and none had the intelligence to manage complex planetary encounters at vast distances without constant human hand-holding. NASA proposed a grand tour mission, but Congress rejected it, approving a cheaper version that would venture out no farther than Saturn. The Jet Propulsion Laboratory's spacefarers responded by agreeing to the plan, assuring each other that Congress didn't really understand the situation. They quietly went to work designing and building 2 tough, smart spacecraft capable of going all the way to Neptune. The ruse worked, and as a result, Voyager 1 has been trucking along for 45 years, 9 times longer than the original plan. It's flown by Uranus and Neptune, crossed the heliopause, and as of now, Voyager 1 is still alive, barreling into the cosmos more than 24 billion kilometers away. However, the spacecraft may be near the end of its scientific life. In recent years, its weakening radio signals reported on the surprisingly complex plasma bubble that surrounds the Sun and marks the designated boundary between the solar system and interstellar space. But a computer problem has kept the mission's loyal support team in Southern California from knowing much more about the status of one of NASA's longest-lived spacecraft. The computer glitch appeared on November 14th, affecting Voyager 1's ability to send back telemetry data. The team has no insight into key parameters regarding the craft's propulsion, power, or control systems. It would be a significant miracle if they managed to get it back, but the team hasn't given up. Other attempts will be made, and the next few weeks will involve transmitting commands for Voyager 1 to try to isolate where the suspected corrupted memory lies within the flight data subsystem computer. One of the ideas involves switching the computer to operate in different modes used during specific planetary encounters in 1979 and 1980. This task is more complicated than it might seem on the surface. The data modes engineers might command Voyager 1 into haven't been used for 40 years or more. Voyager 1 and 2 have an outsized public profile compared to the resources NASA commits to keeping the spacecraft going. Fewer than a dozen people typically work on the Voyager mission, and this number has slightly increased since the computer problem appeared in November. Despite the challenges, the Voyager engineers have been working tirelessly, consulting archived documents to troubleshoot other computer problems and developing new ways to operate thrusters to stave off the accumulation of residue in fuel lines. The declining power of Voyager's nuclear batteries will force NASA to start turning off instruments on each spacecraft by the end of the 2020s. While Voyager 1 and 2 lack simulators on the ground to test commands and procedures, their engineers remain dedicated to finding solutions and keeping these remarkable spacecraft operational, even if they no longer have the luxury of backups. As Voyager 1 continues its journey into the unknown, scientists and engineers will do their best to ensure that this iconic spacecraft remains a testament to human exploration and ingenuity. Don't have any software simulator at 12:04. There's no simulator with the flight at 12:05. Data subsystem, no hardware where we can try it on the ground first before we send it. So, it is difficult to command Voyager that makes people more cautious. And it's a balance between getting commanding right and taking risks in a slightly more far-fetched scenario. The team also suggests it's possible some sort of energetic part could have smashed into the spacecraft. If that happened, it might have created what's known as a bit flip, which means a 0 in the code accidentally became a 1 or vice versa. Still, the team is leaving all possibilities open. That's because, in truth, it might not even be the flight data subsystem that's causing problems in the first place. This theory is just the most likely one to stem from data the engineers currently have. They said because no engineering data is coming back, it's very hard to isolate the source of the problem. Moreover, in a bit of a non-silver lining, remember how Voyager 1's greatest achievement is being the first-ever probe to venture into interstellar space where it's surrounded by untouched stardust and blankets of darkness? Yeah, it's extremely far away from us, and that means communicating with it takes a very, very long time. Specifically, at the time of writing this article, Voyager 1 is more than 162 astronomical units away from Earth. 1 astronomical unit is equal to the distance between our planet and the Sun. In total, it takes approximately 45 hours to complete one back-and-forth command with this spacecraft. Thus, this process may take months. However, to give you a silver lining, though, the scientists have confirmed that Voyager 1 is exhibiting what's known as a carrier tone, which runs along a wavelength that doesn't carry information, but rather acts as a heartbeat. At the very least, we know it is alive. So, if we can fix this, Voyager 1 should be able to continue its science mission. But the Voyagers are already operating far, far beyond what anyone expected of them. We know the more time that goes by, the more issues are likely to arise. Otherwise, managers are also aware of Voyager 1's age. It's operating on borrowed time. So, experts don't want to spend forever deciding what they want to do. Something else might fail. The thrusters might fail. They want to do the right thing, but they can't hem and haw over what the right thing is. They need to look at things methodically and logically, make a decision, and go for it. When it comes time to send up more commands to try to save Voyager 1, operators at Jet Propulsion Laboratory will have to wait more than 45 hours to get a response. The spacecraft's vast distance and position in the southern sky require NASA to use the largest 70M antenna at a deep space network tracking site in Australia. One of the network's most in-demand antennas. Fingers crossed that Voyager 1 returns to its healthy self. But even if it doesn't and is left alone to drift in space, we can be sure its legacy has already been firmly cemented in our books, in our hearts, and in our history. And even if Voyager 1 succumbs to its wounds, the voyage is certainly not over. Don't forget Voyager 2 is still going strong. If we can keep one spacecraft going, the mission will continue. Voyager 2, which looks an awful lot like Voyager 1, actually launched 16 days before its counterpart on August 20th, 1977. And as told, Voyager 1 just happened to get farther faster because it had a more efficient route out of the asteroid belt. Officially overtaking its partner on December 15, 1977, and later becoming the first probe to exit the gravitational influence of our solar system. Voyager 2 does have a bunch of achievements under its own belt though, such as the fact that it's still the only spacecraft to have visited the outer planets, Uranus and Neptune together. The Voyager's joint mission was to simply explore, to plunge through the solar system, sweep across moons and planets beyond our own, and try to go where no spacecraft has gone before. To date, the Voyagers are the only spacecraft exploring interstellar space. and there are no missions that can gather this same data remotely. The team said they've surely been doing their duty, and hopefully Voyager 1 has a little more juice left. But even if it doesn't, scientists wish to make clear that Voyager 2 shall continue to keep the torch lit. While NASA is struggling with its iconic mission, a newly discovered quasar is a real record breaker. Not only is it the brightest quasar ever seen, but it's also the brightest astronomical object in general ever seen. It's also powered by the hungriest and fastest-growing black hole ever seen, one that consumes the equivalent of over one sun's mass a day. The quasar, named J0529 plus 351, is located so far from Earth that its light has taken 12 billion years to reach us, meaning it is seen as it was when the 13.8 billion-year-old universe was just under 2 billion years old. The supermassive black hole at the heart of the quasar is estimated to be between 17 billion and 19 billion times the mass of the Sun. Each year, it eats or accretes the gas and dust equivalent to 370 solar masses. This makes this quasar so luminous that if it were placed next to the Sun, it would be 500 trillion times brighter than our brilliant star. As team leader, an Australian National University astronomer Christian Wolfe said in a statement, "We have discovered the fastest-growing black hole known to date. It has a mass of 17 billion suns and eats just over a sun per day. This makes it the most luminous object in the known universe." But note that this quasar is not newly discovered. In fact, it was spotted in data over 4 decades ago, but was so bright that astronomers failed to identify it as a quasar. This misclassification was spotted in 2023 when astronomers realized it is, in fact, a quasar after having a look at the object's region using the 2.3M telescope at the Siding Spring Observatory in Australia. The new discovery that this is actually the brightest quasar ever was made when the X-Shooter spectrograph instrument on the Very Large Telescope in the Atacama Desert region of northern Chile followed up on J0529 plus 351. A piece of good news: scientists just stated that the South Pole Telescope has a treasure map to the secrets of dark matter, ancient cosmic light that has uniformly filled the universe since around 400,000 years after the Big Bang, could act like a treasure map that guides scientists to the secrets of dark matter. The cosmic microwave background, or CMB, refers to the first light to freely travel across the universe. Its journey began after space had expanded and cooled enough to allow electrons and protons to form the first atoms, meaning electrons were no longer endlessly scattering photons, and the universe instantly went from being opaque to being transparent.